I really believe that the code that I write uh, should have the minimum number of dependencies as possible. The lesser the number of dependencies, the better the code that I write. I feel that most of the things that I prefer should be in my own code and not some other application code. I really don't like using the things in my node modules for most of my stuff. I really like to write do something for my own. So why when I see something like effects, you can see that it's such a big package and it does so much. So why would I have you install this package and use it for like writing your servers, writing your front end as well? Well, a lot of reasons. So in today's video, we're gonna talk about those reasons mostly because I really like effects and what the philosophy behind it is. So so when you typically look at your application, what you see is basically this, the success channel or the optimistic channel. So you mostly write software where you feel that the the things that it is supposed to do is in path, and whatever I write is the behavior that the application would have. But that's not the case at all times. Sometimes the server that you are dependent upon or the providers that you are dependent upon gives you an error, and you have to handle those in your application. In your typical TypeScript application, what you're gonna find is basically this. So this is your try catch loop. So when you have a try catch or something like that, what it's gonna do is basically redirect the error to some other part of application where you have to resolve that error. Yes, that is a good way of solving it, but I feel that mostly that you're gonna have a hard time solving an application problem like that. Maybe sometimes you might also feel that the dependencies that you use at all times also have some errors. For example, one day I was updating my Next.js application. um, Yesterday I was updating my Next.js application, and what I found that moving from 15 to 16, moving from next 15 to 16 has a massive problem in your previous application, because the type safety TypeScript LSP gives an error when moving from old layout to the new layout, where the only thing that is different is basically that the type is not read only. You can see that in your applications. Where is it? Next.js 15. Layout.tsx. Where is it? Yeah. Copy image. Yeah. Moving from old layout to new layout meant that uh, there was gonna be some type issues. So whenever you code gen with the last version of Next.js, you're gonna have a read only over here, and uh, in the new version you don't need a read only in your layout.tsx, but it's not gonna give you an arbitrary error. It's gonna give you an error that's that it did not expect for you to solve. Most of the time, framework authors and library authors take care of all these errors, but not for like application authors, right? Whatever application you are writing, you are supposed to be responsible for it. And most of the time, what you end up doing is basically giving your errors to an LLM, or giving your or wasting hundreds of hours in Stack Overflow trying to find a solution to this error. How do you actually solve such problems? You need to make sure that the errors that you do get, you have a, you have a mechanism to make sure that all the errors and every condition that your application goes through is met. So what does that mean? That means that in a typical TypeScript application, you cannot have a simple success channel. You also need to have an error channel as well as a requirements channel. Now, is that all you require? No, that's not the case, but it's better than just using the success channel as well. You need to have more fine grained control over the life cycle of your application than just JavaScript doing it. So, uh, to explain this to you more better, let's look at a few more understanding on how your application actually works. Your application code uh, lives on top of your node modules, whatever dependency that you have, right? uh, Between this and this, there is also another small thin layer of frameworks, like whatever framework or something that you are using, right? Dependency node modules, and these dependency node modules depend upon underlying low level technologies. And these low level technologies have a robust system that is not propagated to your application. Now, for some reason, in your application there is some error that is in your framework, that is in your dependencies. You can actually solve these errors, but whatever errors that you have in your low level protocols and stuff like that, you're going to have a big problem solving those problems. So how do you actually get uh, get your application to be type safe all the way down? How do you actually get your application to be type safe all the way down? The only way to do that is write your application low level protocols in a language that is more extensible and gives you more control over everything. So that is effects basically, because the errors that you have in these applications bubble up to your application code. You need to make sure that the control that you have also bubbles down. It drills down and gives you more control over all the errors that your application can have. For example, like if there is some like json dot stringify issue, websockets, rtc, right? For example, if you have like a graphql layer, your database layers and stuff like that. So most of the time, all these problems are the stuff that you need to control, and all of these are controllable as well. You need to make sure that the dependencies that you use give you explicit types on how to handle an error case. This is the big problem that most of the time you need to solve. Yes, framework authors and dependencies do sometimes mitigate this, but at the end of the day, when you have an error in your low level protocols and technologies or some other place, you need to make sure that your application is well equipped with handling those errors. You're gonna see a lot of people on Twitter and like X as well talking about effects because of this reason, that the surface layer of their application errors increases from basically this to this. They can handle more of their errors and they can have more robust type system. That's why we say effects is like a big improvement over regular TypeScript, because it gives you more control over application and it helps you schedule and do stuff with the application that is you cannot do with regular TypeScript. Anybody who has actually built like a scheduler in TypeScript is gonna understand that it's a very hard job. And stuff like cron and all this stuff becomes trivial to do with effects. Telemetry as well becomes very easy to do with effects. So if you go to effect.website, you can see that they actually provide a lot of applications and a lot of code to understand why using an error is better than not having an error. You can see in your application that the effects code base is typically smaller and shorter because you depend upon effect wrappers of your application. That means that whatever errors and everything that you build with run on the side, and you do not actually uh, compose your application with regular TypeScript. In fact, you use the minimum number of TypeScript as you can to get to wrap your application with as much as effect as you can. So you have a much more understanding on how your application actually working on a deeper level. So that's what I wanted to talk with you today. So let's see how effects actually work and how do you actually use it in a real code base. So the first thing that I wanted to talk about effect is basically the difference it has between promises. So a typical promise does just only has one type called the return type. You can see in this case, like the answer to life only has one type called 42. It does not actually tell you more about the answer. So you can see that in this case effects is telling you more about the underlying mechanism that returns this value. So you can see that it has a success value, an error channel, as well as a requirements value as well. So the success channel uh, returns the number that you have here. The error channel returns the errors that you might face in your application, and the requirements channel just gives you the requirements of your application as well. So let's see in the next example. You can see the always fail returns an error. That is a typical error, and you can see that the LSP tells me more about what this error is. So if I have a custom error like this, some custom error extends error. So if I error with this, you can see that it's an error now. Typically you have your errors like this, and you define the uh, types as well, whatever error it might have and stuff that it has to do. So you can actually define that in your defects, and you can have much more of a fine grained control over what your application errors might be. You can actually define all your errors in classes and define it over here like this, and now your application has some robust understanding on what these errors are, and these errors bubble up in your application program as well, so you can have much more of an understanding. Let's see that for an example here. So here I am defining a custom error, and I'm using this in a function called divide. Above this you can see the TypeScript equivalent of this code. So divide actually takes in two numbers, number and number, and it's gonna return a number. It's gonna give me an error, never divide by 0, and it's not gonna be dependent upon any other thing but this step. So when we declare a divide like this, you can see that the application is much more type safe. uh, if b exists and is a number, then we're going to succeed with the division value of like a divided by b. And if it does actually give an error, then we have a custom errors to define. So that's what I mean. So whatever error in whichever part of your application you have, it bubbles up on the top, and you need to handle those application errors. So if you see here, uh, pipe, it's gonna run sync this error. So you can see that if you actually try to run this program and you try to do like this one dot, you can see that you're gonna have a tag of never divide by 0 with an error value. It's gonna tell you the error, it's an object, what to do when have to pipe and stuff like this. It's gonna give you a fiber failure basically. It makes more sense to have a fiber failure than a normal error in this case, because you can have much more control over like how your application should perform, instead of just having an error where the application pauses for a second. You can actually like, if you come over like in this case, you can see if I have like uh, catch tags, exactly what I wanted. Here you can see that if I catch tag never divided by 0, and if I have an error, then I'm going to succeed with 0 over here. I'm going to succeed with a value of you can't divide by 0. So now if I have 10 divided by 0, then it's still going to have an error, but it's not going to give me the result of it. Okay, that's new. How do I actually catch a tag? Oh, it's not a tag. Never divided by 0. Never divide by 0. You can't divide by 0. That's the thing. It needs to have the same tag, and your application runs without any errors. So yeah, whatever like tag you save here, it's gonna show up over here as well. If you have a custom error, or you can have multiple errors like this, so you cannot have like some custom error, you can also have like other errors that you can tag, and you can actually solve those application issues in your code. This is what effects does. Now let's talk about promises and how does effect actually uses promises. uh, Before this, I wanted to show you something about Antfu. mm, Antfu has this amazing article uh, on promises and asynchronous programs. So Antfu really shows, in this case, shows uh, an understanding on if your program is a blue color function or a red color function. In this case, a red color function is basically like uh, asynchronous program. That means that if you have an async in your function, that you can only await it inside another asynchronous function. That means that you need to have this chain of asynchronous code that's gonna stop at a synchronous process that's gonna call it and then use its promise to do something. So is your program actually sync or async? We don't know. It's in a superposition of of like actual programmatically solving something. So that's the big problem. You don't want your programs to be in a superposition of like, hey, is it async or is it sync? So how do you actually do that? You actually do that by wrapping your promises in synchronous as well as in effects. Basically, in effects there is no concept of like a synchronous or asynchronous program. Instead you have effects which handle both a synchronous task as an asynchronous task. So how do you actually do that? In this case, you can see that save promise returns a message string and gets back an effect instead of a promise. And when you call this promise, you pipe it to run promise handler, and you basically get your application code handled over here. So whatever errors and everything that you have, you can just solve it the way we solved it above. So that's just how you actually get an application type safe and do not care about the promises like this. In this case, I am using a promise just to show you uh, for demonstration purposes. Mostly you do something like this with effects, where you have a function called get to do's, you have an id, whatever dependency that you require, and you have an effect.try promise that's basically going to do some asynchronous task like fetching a data from a server, which requires a lot of which might have some time, like which might take a little bit of time. So that's the big problem. So you can see that I'm just calling the get to do's over here, and I'm just awaiting it, and then I'm gonna pass it, and then I'm gonna get the to-dos with the response value over here. And if I want to get the to-dos value over here, I can just do JSON and it just works. In this case, I'm using an await again, but you can see that if you have a program like this, you actually just need a single program with a generator function syntax. I'll talk about this a bit in a bit as well. I just wanted to show you that in effects, promises and synchronous and asynchronous code does not exist. Instead, you have a single superposition called effects, where you handle everything including the synchronous part as well as asynchronous part. And how do you actually do that? You do that with your generator syntax. Now what does a generator syntax mean? A generator syntax basically means that it starts with a function star like this, and that means that on every part of this application you're gonna stop for a minute. You're gonna stop with your application and you're gonna pause your application and you're gonna run that step. So basically everything becomes a synchronous task, an asynchronous task basically. So yeah, you can see in this case I'm fetching three to dos, I'm defining them in an array, and then I'm gonna define another function here, turn to JSON, which basically tries to convert it to a JSON value as a to do, which basically gives us a to do. And whatever error I'm gonna have, I'm gonna tell it like this unknown error like this basically. So if I actually want to use like an actual error like this, so I'm gonna say uh, w JSON error, and I'm gonna have it over here and wjson error, and whatever problems that I face, I'm just gonna be able to propagate it to the top of my application, and whatever unknown exceptions and stuff like that I have, I'm gonna have those errors in my application much more deeply, and I'm gonna understand whatever I need to do to solve those application errors. This is how you actually solve like most of your TypeScript issues. 99% of your TypeScript issues are gonna be solved using effects. And this is not just for like library authors or framework authors, this is also for application authors. That means that whatever application that you are writing is going to be type safe on a level where you have to handle every case and you have to handle every problem that your application might face in the future. So yeah, that's all basically how effects works. Now I wanted to talk about the requirement channel. Why do we actually read a requirement channel, right? So to understand how why do we actually need a requirement channel, you must face something like this. This is a function that you might have seen 100 times. There is this connect to database query. You pass a query and you wait for a database to connect, and then you run the query in the database. Now, if you are like a TypeScript author, uh, this has always made me mad because I don't know what this function might throw. It does not return anything. It does not give me any functional equivalent or lets me handle what this application is doing. Now this is just for like uh, if you see this code in the wild, like for example mongoose or something, you're gonna understand that it's not made for you for TypeScript world and like functional programming. It's made for just interfacing with mongoose correctly. So mostly you can do something like this in like effects. You can have a database context, and you can basically share it like this. I mostly generally prefer doing something like this where I'm passing the database like this and I'm awaiting uh, based on the database context, because I don't know what it's gonna return. But in effect lang it's very simple to do. Basically you have to handle all those dependencies or your application might fail. So that's the main thing that I find errors in typical JavaScript applications, is because I cannot control this application like this. And the best thing I could do right now is basically have it passed inside as an argument and handle those arguments outside, which is the big problem that I find TypeScript has. This is also not an issue for you to solve. This is an issue that just exists in TypeScript and JavaScript land that I wanted you to talk about it. If we could handle the requirement array of an application, we would probably be fine. So that's why requirement is necessary for effects to handle. It's for the future of TypeScript, not for the current implementation of like most libraries. So let's see another example of most another example of how do you actually use effect. You can basically have like random numbers and stuff like that. So if you go to effects website again, there are a lot of more things that you could do. There are a lot of more topics that we need to cover, like for example concurrency, composability, uh, resource safety, type safety and everything. And another advantage of effect is basically uh, another advantage of effect is basically that LLMs do not understand it. So for LLMs to understand something like effect, they need to see in the future of a program what it might do, which it cannot do because it only exists as a process. If you are a process and not a robot, you have your process running at all times. As a human, you cannot continuously think about something and how your application performs. So basically I want you to use effects because it's the most best way to do something in your application. So yeah, that's all about effects from this video. We would talk more about effects in the upcoming videos and like how do you actually make an application. In fact, I'm gonna convert uh, this big function over here main into an effect uh, into an effect based architecture and how to actually solve these problems. So in the next video we are going to talk about it a bit more, and we are going to have like understand why we need effects more. So yeah, thank you so much and we'll see you in the next video. Thank you so much. Bye.